Hello! This lesson has been prepared by Jordi Martinez Vilalta, a forest ecologist and expert in plant physiology, and Joan Pino, a landscape ecologist expert in urban forests. The lesson will approach us to the main concepts of carbon cycle in forests, both urban and non-urban, and give some definitions of concepts and terms to be used, for example, in understanding the carbon dynamics in forests and calculating their carbon footprint. As first step, we need to introduce some concepts which probably are not new to you. We start with photosynthesis, that is, the metabolic process by which green plants and some other organisms transform light energy into chemical energy. Photosynthesis thus incorporates CO2 into the ecosystems in form of biomass. Please remember that 2.4 grams of biomass are equivalent to 1 gram of carbon. Let's also introduce some other concepts that are key for understanding carbon cycle in forests. The first is gross primary production, GPP, which is the amount of carbon biomass that primary producers, so plants, create per unit of time. GPP is different from net primary production, NPP, which correspond to the remaining primary production after subtracting from gross primary production respiration of plants, which is associated to both growth and maintenance. And GPP is also different from net ecosystem production, which is the difference between gross primary production and ecosystem respiration, which includes respiration by plants and heterotrophic organisms such as animals and microbes, and also accounts for losses due to disturbance. And finally, leaf area index, LAI, corresponds to non-dimensional ratio of one-sided green leaf area per unit ground surface area, both in square meters. Efficiency of plants in incorporating light energy into the ecosystems is very low, as net primary production usually equals to less than 1% of total energy. This is because of most of the energy flowing through the ecosystem is lost as heat or it powers evapotranspiration through trees. Moreover, most of the energy taken in by consumers is lost as respiration. Now, let's see the set of carbon compartments that are key to understand carbon cycle in forests. The first is living biomass, made up by above ground structures, including stems, branches, bark, foliage, flowers, fruits, and seeds, and below ground structures, including cores and fine roots and stumps. The second compartment is dead wood and litter, corresponding to dead biomass in soil surface. And the third one is soil biomass, including soil organic carbon. This compartment results from the balance between different carbon fluxes. Both above and below ground biomass are the outcome of net primary production minus heterotrophic respiration and exported carbon, for example, due to disturbances. Soil organic carbon, in contrast, is the result of litter fall and root and branch inputs minus soil heterotrophic respiration and carbon exports. Both living and soil biomass usually are of similar importance in forest ecosystems. To sum up, gross primary production of trees depends on their leaf area index, which in turn is controlled by a set of genetic and environmental factors. Some fraction of this gross primary production is lost through respiration because plants respire all day and night. And the resultant is the net primary production, which corresponds to the net carbon gained by plants. But how to measure net primary production? At a stand level, it can be measured by different approaches. For example, by measuring increase in trunk diameter, DBH, to obtain carbon stock change. Also, by measuring CO2 flux in leaves, stems, or entire trees using chambers. This flux in chambers is the difference between photosynthetic and respiration rates and equals to net primary production. This map shows the global distribution of land and ocean net primary production, NPP, which has been estimated from spectral data that has been gathered from the MODIS satellite of NASA. You can see that net primary production in terrestrial ecosystem ranges from 0 to 2.5 kilograms of carbon per square meter and year. It also should be noted that land and oceans concentrate approximately 55 and 45% respectively of total net primary production on Earth. In any case, net primary production in forest ecosystems is strongly limited across the globe. The most important limiting factors are sunlight, water availability, and temperature, whose effect depends on the regional climate. In Europe, net primary production of temperate forests is mostly limited by sunlight, that of boreal forest is mostly limited by temperature, and that of Mediterranean forest is mostly limited by water availability. However, it should be noted that net primary production is not the final metric of carbon uptake in forests. A fraction of this production is lost by consumption of heterotrophic components of the ecosystem, for example, animals and fungi, or it is lost and exported by disturbance events, for example, leaves and branches dropped. The difference between net primary production and these loss correspond to the net ecosystem production, which is the actual metric of carbon uptake at the ecosystem level. But how to assess some of these processes? Leaf litter decomposition, which is the loss of mass and nutrients in leaves, is usually measured using bags of decompositions, which are located, protected to the ground surface, and are weighted in successive times. Soil respiration is another key process for understanding net ecosystem production in forests. It is usually measured with cameras connected to measures of CO2 concentration or with sensors of concentration directly installed on the ground. Roots and mycorrhizae can be excluded to estimate the contribution of the heterotrophic respiration. But how to measure this so important variable for understanding carbon cycle in forests? Indeed, net ecosystem production is now measured by different approaches. Carbon exchange can be measured at flux tower and global scales with very different spatial grains and extents and with different partitions of fluxes. For example, flux towers have footprints of approximately 1 kilometer, while satellite inversions resolve hundreds of kilometers. Flux site scale measurements are made directly in situ, for example, using DBH or with measures with small scale sensors. In contrast, space are done with a variety of remote sensing instruments. All these methods show us that ecosystem net production varies much less among biomes across the world than its components that are gross primary production and respiration. Indeed, tropical forests show the highest gross primary production and respiration rates, followed by those of temperate, Mediterranean, and boreal forests. However, temperate, Mediterranean, and boreal forests exhibit similar net ecosystem production than tropical forests, despite the higher gross primary production of this last, which is compensated by higher respiration rates. Many thanks for your attention. We hope that you have enjoyed this presentation and that it helps you to understand the basic functioning of carbon cycle in forests.